Hello. In the previous lectures, we discussed about microarchitecture of a MIPS 32 processor, and before that we went through the architecture of a MIPS processor, and even before and in between we had discussed the digital fundamentals required for the whole processor, right? So basically, if we consider this as our computer system, up to now we have discussed how we implement this CPU, right? And we had discussed the instruction set. Now actually what is remaining is this input output systems, the main memory and the cache memory, right? So in this lecture and in 2 or 3 lectures to follow, we will be discussing about the input output systems, and later we will be moving on to the main memory and cache memory. Okay, now let's move forward. Right, so how is this devices, right? Input output devices means devices like your keyboard, your mouse, your speaker, your that Ethernet cable you connect, your display, whatever you are connecting, whatever you are connecting to a processor other than the main memory is considered to be an input output device, IO device. Okay, even the hard disk of a computer is considered to be an IO device. So how do you actually physically connect? In the microarchitecture lectures we had gone through earlier, we had considered the concept of something called as a data path, right? What was the data path? Data path was the collection of devices or state elements through which instruction and data was flowing, and then there was control path. So though we considered the elements, and in between the elements there were lines. We just drew lines to show that okay, this is connected to the other and data is flowing from one element to the other element, or control is being sent from the control unit to certain elements, right? So how is this data being moved? And even when we are considering the processor being connected to the memory and other devices, how is this being done? That is being done using what is called as a bus. Okay, basically bus is just what do you say, certain number of lines, let's say, or wires. Just you can say wires physically, or something equivalent to that. That is some conductors which can transfer currents. That is bus in the broad sense of talking. But it then there is the thing that all buses are not the same. We divide the bus into different parts depending on our requirement and how we use it. Okay, so just remember this, that buses are lines or connections or wires or conductors used to connect processor with the memory and input output devices. Okay, mind you one thing, there is always an internal bus which is used to connect the components within the processor, and then there is an external bus which is used to connect the processor with the other elements. Okay, so the bus that we saw can be split into these three, which is address lines or the address bus, data lines or the data bus, and the control lines or the control bus. I think I have discussed this in the class earlier, but I just want to just refresh this so that it will be easier when we move forward. Okay, address bus, data bus, and control bus. And it's not like we are directly plugging in or connecting the input or output device to our bus. There will be some intermediary devices. Okay, some interfaces will be there. So in order to handle the address, we will be using some address decoder, and to decode or understand the control signals coming, we will be using some control circuitry, and to handle the data, that is maybe to act as a buffer or something like that, we use some data and status registers. Okay, just remember that we have the bus, which is of 3 types. We have the input output devices, and then there are some intermediate devices which has certain purposes, and they will be connected respectively to the address, data or control buses. Okay, the next concept that you should know is called as input output mapping, IO mapping. Okay, basically mapping is nothing but it defines how the processor, how the CPU views, or how the processor sees the input output devices, right? So the processor can either see the input output devices as input output devices itself, right? So that is, the processor can see a keyboard as a keyboard, or it can see a mouse as a mouse, or a monitor display as a display itself. That kind of mapping, okay, that kind of identification of input output devices is called as an isolated IO or IO mapped IO, input output mapped input output. That is, input output devices are mapped as input output itself, right? The advantage is that like there will be specific lines given for this. Okay, there are separate lines given for this, therefore it won't affect other systems, which is the memory. We'll come to that. Okay, separate lines are given, separate address is given for this. Okay, special commands will be there, but the problem is that the disadvantage is that all of those is limited. That is, this commands that we can use, that is the instructions which are used to access these input output devices. When we are mapping them as isolated IO, will be limited. The number of devices you can connect as IO will be limited. So these kind of issues are there. The other method is memory mapped IO. Okay, the first thing is isolated IO or IO mapped IO. The other is memory mapped IO. Here there will be an address space given to, that is a certain address from 000 something to FFFF something, depending on the number of bits of the address line, is usually assigned for memory, right? In memory mapped IO, what we do is we assign some of these addresses for input output IO devices. So what is the thing here, what is happening? Then the processor will identify these certain memory locations as memory locations only, but these addresses will actually be connected to IO devices, right? For example, if we assign say F0 to FFFF as input output devices in the memory space, then whenever the processor is giving the address FFF0 to FFFF, it will be considered as in memory, but actually the processor is connected to input output devices, right? The advantage is that there is a possibility of connecting more number of input output devices, right? Earlier, the thing is that in a processor, the memory space, the address space for the memory will be larger. The address space is the range of addresses. Okay, the address space for the memory will be larger, and the address space for the IO devices will be smaller. So when you are using a memory mapped IO, then the advantage is that you can connect more devices. And obviously in any processor system, the instructions or commands given for memory will be more. So that is an advantage. So you can, when you are using memory mapped IO, you can use all of these commands for accessing our peripherals also. But the disadvantage is that this eats into the memory, right? If you have the possibility of connecting say 1024 memory locations, and you are using say n peripheral devices, and you are mapping them as memory mapped IO, then you are losing that much memory space. So usually we only use isolated IO, and depending on certain conditions we may use memory mapped IO. Okay. Now that we have done a brief introduction regarding input output devices, how they are connected to the processor through a bus, and how they are mapped or how they are viewed by the processor, the next topic that we have to cover is input output techniques. Okay, that is how actually we do the data transfer. The purpose of connecting these input output devices to a processor is that whatever data you have to input to the processor or output to the device, that data transfer has to happen, right? So this IO techniques, when we mean that, or modes of accessing input output, it means that how we are actually transferring data, and how depending on what conditions or priorities or criterion these devices are selected. This will start in the next lecture. Thank you.